guys, today we're going to talk about solutions. Let's get started. So first off, a solution is a homogeneous mixture, which means that it is made up of different substances that are the same throughout. Remember, homo means same. Compared to a heterogeneous mixture where we have different substances that are layering themselves. There are two parts to a solution, the solute and the solvent. The solute is going to be what is dissolved in the solvent. Solute is present in smaller amounts than the solvent. Some real life examples of this is when we go to put sugar in our tea or coffee. Sugar is going to be the solute. Coffee and tea are going to be the solvent. Coffee and tea are basically water, right? So that coffee and tea is going to dissolve that sugar into the solution. If we go to make salt water, right, and we put salt into the water, the salt is going to be the solute, and the water, again, will be the solvent. If we go to make chocolate milk with a chocolate powder like Hershey's or Nesquik, that chocolate powder is going to be the solute, and the milk is going to be the solvent. Water is a universal solvent. It works for almost everything, not everything. Like we know water will not dissolve oil, right? So there are some things that water will not dissolve, but a lot of things are dissolvable by water. If two liquids can be mixed together, they are said to be miscible. So that means that we can dissolve the one into the other. And a good example here is water and ethanol or isopropanol, rubbing alcohol. If we take that and we put it into water and we shake it up, we can't tell the difference. The two have mixed together, and that's how we dilute ethanol and isopropanol. If two liquids are immiscible, they do not dissolve in one another. So, like I just said on the last slide, water and oil is immiscible. If we take water and oil and we put it into a bottle and we shake it up, the oil is not going to dissolve in that water. An example of that would be like salad dressing, right? If you take a salad dressing like oil and vinegar or a vinaigrette, it's always going to separate out. You have to shake it up every time you want to go use it, and the oil and water separate back out between uses. Electrolytes versus non-electrolytes. When a solute dissolves in water, the resulting solution is either an electrolyte or a non-electrolyte. An electrolyte is something that conducts electricity. Ionic compounds will always dissolve into ions, right? Let's review that for a second. So we'll use our example here of sodium chloride. So we have a sodium ion, right? We have sodium chloride like that, and they're bonded together. Remember that sodium is a metal, and it does give chlorine one electron. And that makes the sodium positive and chlorine negative. And so when these guys get into water, when we add sodium chloride, salt, into water, they dissolve out, because remember, water, we've got our oxygen up here that's a little negative, and we've got that hydrogen on each end there, and those guys are a little positive. And so this polar water breaks up that sodium chloride, and the chlorine ions are going to hang out near those positive hydrogens, and that positive sodium is going to hang out near that negative oxygen. And so the sodium chloride is going to break down into those ions and fill in between those water molecules. Non-electrolytes do not conduct electricity, and that's going to happen with covalent compounds. So here we have sugar, C6H12O6, glucose, and covalent compounds are not going to break down into ions because they don't have ions, right? These guys are all non-metal, so they're sharing very nicely. There's no transfer of electrons. They're just sharing all those electrons together. So when sugar dissolves into water, it's going to stay as a whole molecule. So I'm just going to put a little glucose here. It's going to stay as that whole covalent molecule. And it's going to go in between the water molecules. So like they're going to disperse out, kind of hang out, mingle, so to speak, in between those water molecules. But they're not actually breaking down into ions like the sodium chloride is. So these guys are in ionic form and transferring those electrons. And so when we put electricity through it, it can conduct. Whereas here, these guys are staying separate and there's no charge because we don't have those ions. So degrees of saturation. Solubility refers to the amount of a substance that will dissolve at a specific temperature to produce a saturated solution. So let's look here. What is a saturated solution? So a saturated solution contains the maximum amount of dissolved solute. An unsaturated solution contains less than the maximum amount of dissolved solute. That means if a solution is unsaturated, we can add more solute. If it's saturated, that means that the solvent cannot hold any more solute. So let's put this to a real life situation. Let's think about iced tea. Okay, so if you have iced tea, it's cold, right? We put some sugar in there and we stir the iced tea. The sugar molecules are going to go in between those water molecules that make up the iced tea. Well, if we add too much sugar to our iced tea, what happens? The sugar goes to the bottom of our iced tea, right? We can see it in the bottom there. And if we're drinking out of a straw, we know we can go to the bottom of our iced tea there and get a little extra sugar, right? So if we have an iced tea, here we go, here's our iced tea, and we put a little bit of sugar in there and we stir it up, the sugar molecules are going to hang out in the water. Not that we can actually see them, right? But so that would be unsaturated. That means that we could add more sugar and the iced tea would hold it. We can add sugar right up to the point where the iced tea can hold just as much sugar as possible. And then we can pass that and we can go to super saturated, right? And that's where if we add so much sugar that the iced tea can't hold it anymore and the sugar goes to the bottom of our iced tea. That's a super saturated solution. It's yummy, right? We can do the same thing when we're making chocolate milk, right? If you add just enough chocolate milk, it stays in the milk, but if you add too much chocolate to your milk, we know that it settles to the bottom, and by the time we get to the bottom from drinking our chocolate milk, there's a whole lot of chocolate on the bottom, right? So that would be a super saturated solution. And we see here A great example in nature is honey. Honey is a super saturated solution. There is more sugar than liquid content. That's why it's so viscous or thick. And when we go to make rock candy, where you put so much sugar into the solution when it's hot that when it cools, the sugar comes out of solution and forms that rock candy. Which brings me to a question. What is the difference between putting sugar in a cold solution compared to a hot solution? Like putting sugar into cold tea compared to putting it in hot tea. What do you think? All right, let's take a look. Some factors that affect solubility. Solid dissolved in a liquid, temperature is a huge factor. That's what I was just talking about there. Cold tea compared to hot tea. Well, remember when molecules are colder, they move slower and they're closer together. So in that cold tea, right, those water molecules, okay, I'm drawing them bigger than they actually would be, right, are going to be closer together and moving slower. But when we have our cup, I'm trying to draw a little teacup here, ooh, teacup fancy, those molecules are going to be further apart and moving faster. So if the water molecules are further apart, then we can fit, let me use a different color here, we can fit more sugar in between those water molecules. Whereas when they're cold, we cannot fit as much sugar in between those water molecules because there's not as much space between those water molecules. But in the hot tea, the water molecules are literally further apart from each other, even though it's still a liquid, right? It might be close to boiling or boiling hot, and those water molecules are literally further apart from each other and more sugar can fit in between. So a hot substance can hold more solute than a cold substance. Now let's look at gases. For gases dissolved in a liquid, like soda, right? A Coca-Cola or a Pepsi or Mountain Dew or whatever, carbonated sodas, are actually a liquid with carbon dioxide gas forced into them. And so we see as the temperature increases, solubility decreases. So that means that that gas is going to be forced out of the liquid. We know if we open a soda and we pour it into a glass and we're sitting outside on a nice hot day, that carbon dioxide, that fizzing is going to leave our liquid faster and go flat faster. This is because those molecules are moving more rapidly, they're close together, and they're forcing the gas out. On the other hand, we also are affected by pressure. If we increase pressure, then solubility increases. We know this from that characteristic sound when we open a soda, right? If you have a pop top or a screw top, when you have a brand new soda and you open it, it makes that, right? That sound as the gas released. Because when they bottle sodas, they force the carbon dioxide gas in there under pressure and they close it. So they're keeping that carbon dioxide gas in the liquid under pressure. But if we release that pressure to our normal pressure here, all that gas wants to leave. So increased pressure on a gas will force it into the liquid and make the gas and liquid more of a mixture together instead of that gas leaving. All right, let's see. Let's stop there for today, and I'll see you next time.